Hello and welcome back. In the last video, we learned how to set up the greet project using the command icpp-init and what each file inside the greet folder signifies. In this video, we will take the next step in our journey of creating and deploying a canister, which is to generate a WebAssembly wasm file that can run on the Internet Computer blockchain. We discussed WebAssembly in a previous video where we learned how to install the WASI SDK. To quickly recap, WebAssembly or WASM is a low-level binary format that allows code written in languages like C++ to execute efficiently inside WebAssembly runtimes, achieving near-native execution speeds. Let's go ahead and begin the execution steps. To build the WebAssembly file, go back to the Visual Studio interface and run the following command: icpp space build hyphen wasm and hit enter. This will compile a program and create a new folder called build. Inside this folder, you will find the greet.wasm file, which is our WebAssembly binary. Let's wait for this process to complete. There we go. There is a new folder inside greet called build, and here is the greet.wasm WebAssembly file. Now, how does ICPP know what to compile? Well, the answer to it lies inside the icpp.toml file. It has the step-by-step instruction that ICPP follows to generate our WebAssembly file. The key sections in the icpp.toml are build library, which compiles our static libraries, and build wasm, which uses the compiled libraries to create our WebAssembly file. Let us understand this in a bit more detail. First, compiling the static libraries. Before creating the WebAssembly file, ICPP first compiles the static libraries. These libraries contain reusable C++ code that we later link to our WebAssembly modules. For example, look at this section of the icpp.toml file. This tells ICPP to compile all C++.cpp file inside the libhello folder. See this here, libhello folder hello.cpp, and also include all the header files inside the libhello folder. So this key cpp include dirs, it tells ICPP to include all .h or .hpp files inside the libhello folder. So you see there is hello.h inside libhello. If there would have been more header files .h or .hpp, they would also have been included. And create a static library libhello.a file inside the build library folder. So if you will see this build library folder inside libhello, and there is libhello.a, which is our compiled static library. And similarly, there is another section in this icp.toml file for libworld static library. This has exactly the same structure. You can see there are world.cpp and world.h file inside the libworld, and inside the build library there is libworld folder, and there is the static compiled library libworld.a. Now let us understand the creation of WebAssembly file. Once the static libraries are compiled, ICPP uses them to create the final WebAssembly file. Here is how the build wasm section inside the icpp.toml is configured, which are the instructions for the compiler to know how to create the WebAssembly file. Let us understand this. This means the name of the canister is greet. This says where to find the canister interface definition file. So it is src-greet.did. This tells the compiler where to find our C++.cpp files. So it is inside src.greet.cpp. This tells the compiler where to find our header files. So it is libhello, libworld and src vendors. There is our hello.h file inside libhello, world.h inside libworld, and src vendors json.hpp. Once all these files are found, icpp-pro compiles the C++ files, including all the header files mentioned in these directories, to create a .o file present inside the build folder. So you see this src-greet.cpp.o. So it creates the .o object file and then links it with previously built static libraries. So inside build library we have libhello.a inside libhello folder, static library libworld.a inside libworld folder, and we also have iccandid.a inside iccandid folder. So icpp-pro links this .o object file with the .a files to build the final greet.wasm WebAssembly file. And that's it. In this video, we learned how to build the WebAssembly file using the command icpp build wasm, and how the icpp.toml file dictates the whole building process. In the next video, we will learn how to deploy the canister and how to run it. So, see you in the next video. Thank you.